Hi everyone, I am Jack Yang from Stanford University. Today, on behalf of my co-authors Yingtian, Yuhan, Karina, Daniel, Anisha, Shuning, Tianshi, James, and Monica, I would like to present ReactGenie, a development framework for rich multimodal interactions using large language models. Today, we have powerful graphical user interfaces. I made my presentation in one of them. Here's an example, PowerPoint. PowerPoints have support for objects like text, pictures, shapes, and allows me to adjust fonts, colors, and line settings to a very precise degree on my graphical user interface, or GUI for short. However, sometimes it becomes slow and tedious. For example, for batch actions, I would like to maintain my animation to happen in 0.3 seconds instead of the default 1 second to save time. So I would have to do it manually for all objects on all slides. Similarly, for less common features, to adjust the underline style, I would have to go through menu after menu to get to this point where I can change the settings. In contrast, we have voice interface or natural language-based interfaces today, like ChatGPT. It allows users to simply state what they want in natural language and they get an answer in plain text. In this case, it can even tolerate some typos. However, it lost precise and directness of graphical user interfaces. In this case, I'm trying to draw an image where the sphere is center aligned with the cube. So I asked AI to make it, in the first generated image, the sphere is actually on the floor. So I asked AI to make it higher, but then it exceeds the height of the cube. I then asked it to go a bit lower and I can go back and forth. But that's not a good experience. I'm already missing the experience of being able to adjust everything precisely in a graphical user interface. So how can I use voice and touch interaction to navigate a tedious and repetitive task in software today? So here I show a feature in Windows called Windows Copilot. It is built to help users navigate daily tasks in the Windows operating system. I have downloaded Oculus setup files multiple times when troubleshooting my VR headset, and now it's resolved, I want to delete all of them. So I asked Copilot, how can I delete all the files starting with Oculus setup in this folder? However, after a while, it asked me, do I want to open command prompt? So this bridge between voice interaction and graphical interface is called function calling. OpenAI first introduced it, but it's also present in many competing language model providers. AI select a function when it sees fit, and then it sends a list of parameters to the function. However, it can neither chain function, like find files and then delete it. It also cannot apply action to a list of objects, like deleting all the files matching a specific criteria. So I draw this figure representing today's multimodal apps ecosystem. User can interact with apps by touching and seeing changes in graphics, and user can also interact by expressing voice command through AI. However, when the voice command needs to access tasks in apps, it is limited by this narrow function calling interfaces. So going back to the Windows Copilot example, no matter whether I want to open an app or delete a file, or if Windows eventually implements this delete file function, maybe I want to delete files smaller than 100 megabytes. This requires a new function to delete and filter by size, right? So all of them go through this function calling interface. And the user obviously have diverse expressions that are quite limited by this single function calling interface. It feels almost impossible to feed all the diverse stuff people want to do from day to day through this interface. Or is it? So let's think about how we have been able to handle the user's diverse expressions through graphical user interfaces. So we have this thing called UI frameworks. This is decades of work from our HCI community, and we have been building best practices and engineering solutions into frameworks like React, Vue, Angular, UIKit, and Compose. So the UI frameworks enable developers to build apps after a simple 12-hour crash course, and the app will be quite usable. However, in contrast, today, the apps will have a consistent look and feel and follow a lot of UI best practices out of the box. In contrast, today, not even Microsoft, a trillion-dollar company, can build a good multimodal app interface into Windows. So what if we can apply the same approach of a graphical user interface framework to multimodal interfaces? So today I propose ReactGenie, a multimodal interaction framework. ReactGenie extends the functionality of UI frameworks to generate an interface for multimodal interactions. For developers, it uses the same code base as graphical user interface code, which you're already familiar with, and those code provide the app's logic to the multimodal interface. The framework will automatically generate an efficient interface for voice and touch, and also provide an expressive interface that far exceeds the capability of function calling and getting close to the level of natural language. So I want to first talk about the target interaction that we're working with. So the first type of interaction we're working with is accessing off-screen content. So let's say we're in this Home Assistant app, and then I noticed that there's some activity in my living room, and I want to know if there's anybody, there's nothing broken, like nobody break into my living room. So I want to check the log in the same room, right? And now it should understand, which room am I in, and then find a log in that room, and then show me the status, the history of that log, so that I know, like somebody enters the room, so nothing's broken, it's just my wife. Okay, and then the second kind of features that we're trying to work with here is accessing off-screen functions. So let's say I just watched this YouTube video. YouTube has this function where I can share this video by typing this button. But there are so many features that YouTube supports, but it's not directly displayed in the app. For example, I want to share this account, right? There isn't a button for that. I also want to share this comment, but there's also not a button for that. There's so many things that you might want to do with the app, but it's not directly exposed with the button, although the app actually supports this function. So we want the users to be able to access those. And finally, we want users to be able to compose all of the access together. For example, I'm in this app where I can order some food. And now I want to say, I want to reorder. There isn't a reorder button. I want to reorder what I have ordered before, the meal I've ordered before from this restaurant. So that's a retrieval of off-screen content and using an off-screen function. So I want to say, order what I've ordered last time. And then it should be able to just place the order. So the way ReactGenie works is we implemented this using a shared object-oriented state abstraction, and then this is basically similar to how people are building graphical user interface app these days. And then we in this represent the data and logic of the app, and then the developer uses decorative UI components to represent the UI. And this is all kind of standard. And then we only ask them to provide some extra annotations. So having different modalities, naming the graphical user interface and the voice and multimodal interface share the same state abstraction, allow developers to use ReactGenie to seamlessly integrate and compose those modalities to deliver multimodal interaction. The object-oriented state abstraction in ReactGenie encapsulates state changes in each step as method with strictly typed parameter and return values. So this is basically what developer wrote, and the annotations is the new thing they add to support multimodal. And this allows easy and accurate composition of methods and properties of existing states for executing complex multimodal commands. For example, if the user says, add food to a new order, ReactGenie will be able to use this large language model-based natural language parser to translate the transcript into a compound of two function calls: create order and add item. So let's see ReactGenie in action in a food ordering app.
Reorder my last meal from this restaurant.
So the user tap on a restaurant and say, reorder my last meal. And what will happen is ReactGenie will first use this natural language parser to translate the user's voice command to ReactGenie's domain-specific language, NLPL. And however, here we do not yet know what is the restaurant that the user is referring to. So therefore, ReactGenie first reads the tap point from the UI and uses the developer's UI component code to map the tap point back to a state object. And now ReactGenie can execute the DSL. It first resolves the last order from this restaurant. And then it creates a new order and add the same food in there. Finally, it uses this UI component code again to map the result back to a graphical user interface and text feedback. So that is how ReactGenie reuses the developer's existing graphical user interface code to support multimodal interactions. So we want to conduct an evaluation of how good ReactGenie is as a framework. The paper will have more details on it, but here I want to highlight these 4 studies. So first we try to assess how well a developer can use ReactGenie to build the app they want. So we try to build 3 different apps. We find that different UI naturally decompose into components representing different ReactGenie state classes, and we also find only 5% of the code, which is those annotations, must be written to handle multimodal interactions. This proves our thought that we can actually generate this multimodal UI from the same graphical UI code without too much addition. And then we find this app. We basically we try to find this application ReactGenie timer that allows user to we build this app ReactGenie timer that allows user to create a start and pause timer and then filter by certain category and filter by remaining time. And then we then ask novice developers to actually learn ReactGenie first through a tutorial and then build this app we just specified here. We did give them some boilerplate graphical user interface code because people are already familiar with it to save time. We find that after this user study, developers have a high comprehension of framework functionality. They answer 99% of the questions right. And then participants can finish this app, basically modifying this app from a GUI app to a multimodal app, average of only 67 minutes. And then we also get a lot of positive feedback from developers. And there are developers even asking us, whether they can use this framework in their real life applications. So on the user side, we first want to understand if this parser we just said, if it's working well or not. So we did this elicitation study to gather commands that people might want to use when they're interacting with the app multimodally. So we find we collected 288 commands, and then out of them, 172 commands are our targeted interaction, meaning the interaction where the user are using both voice and touch to achieve something more interesting, not just like simple button clicks. And then we find that out of them, 101 of them are supported commands, meaning those are supported by the logic code that we build. And then ReactGenie's parser can parse them and know that a lot of them are pretty complex, involves multiple steps, and then we can parse 91% of them correctly. And then out of the unsupported command, meaning some of the functionality are not yet available, the parser can still generate sensible NLPL, sometimes referred to function that is not yet implemented, which is actually quite useful as an indication of what also needs to be implemented for the developers. So we also tested the user experience with ReactGenie generated UIs. And then we tested with 16 participants with a within subject design, and then we tested a multimodal version generated by ReactGenie and a graphical user interface only version. We find ReactGenie can save 40% of the time, have lower cognitive load, and higher usability. And 11 out of 16% prefers multimodal UI, and then the 5 preferred the other one, stated that they have trouble with voice recognition before, so that was the core reason. So the takeaway, I think the takeaway from this talk is that the right abstraction is the key in building a multimodal toolkit. In our case, ReactGenie provides this right abstraction between app logic and input and output. So I want to say composable abstractions that better separates multimodal input and output from the computational model enables developers to create intuitive, efficient, and capable multimodal interfaces in less time with less training than using traditional development frameworks. I want everybody to try and build with ReactGenie here in this link. Everything's open source, and thanks for watching.